Okay, let's talk about how we actually do these stoichiometry calculations. Now, the key, and this is why it's in big bold with stars on it, all stoichiometric calculations begin with a balanced chemical equation. We just looked at that. I just talked about that. You have to have a balanced equation before you can do anything else when you're doing these calculations. Now, I'm going to show you three different ways to solve these problems, and we're going to look at mole to mass, and mass to mass stoichiometric problems. Now, the mass to mass, those are going to be the most common ones that we're going to use. Because when you're doing a lab, for example, you can't measure moles, you can measure grams. So it's very unlikely that we know the moles to begin with. Most of the time we're going to know the mass of something. So we're going to really focus on those mass to mass calculations. So let's go through what our steps are to solve these problems. So again, number one, you always want to write a balanced chemical equation. Okay, and then number two, you want to determine where to start your calculation by noting the unit of the given substance. So we want to read the problem, figure out what do we know, and then those are the units that we're going to start with. So if we're starting with mass in grams, we have to convert it to moles. If we're starting with moles, then we want to go straight to our mole ratio. So it's going to depend on what we're given as to where we start. And then the next thing is we want to figure out where we want to end. What units are we trying to get for our unknown substance? If we're trying to just find moles, all we have to do is stop after the mole ratio. If we're trying to find grams, we're going to have to convert moles to grams. So it's going to turn out looking something like this. Okay, I'm going to give you kind of a little formula to follow when you're doing these stoichiometry calculations. If I can make my pen work. Here we go. All right, so usually you're going to be grams of some given in the problem. And that's what we start with. We always start with what we know over 1. And then we will need to convert that to moles. So we would use the molar mass of the given. Okay, so we'll make a little note. This is molar mass. To convert the grams that we know into moles. Okay. Then we want to get from moles of the thing that we know to moles of the thing that we're trying to find. And this is where we use our mole ratio. So we would use our balanced equation to get moles of our unknown and put moles of what we're given on the bottom so that those moles cancel. So this step right here, this is the mole ratio. And that comes from the balanced equation. Okay. Then the last thing we would need to do would be go back to grams using our molar mass. So again, grams per mole. And this is the molar mass of the thing we're trying to find. Okay, so if we take a look at our units, our grams are going to cancel, our moles are going to cancel, the other moles are going to cancel, and we're going to be left with grams. So that's how we would do mass to mass calculations. Now, if we want to just do mole to mole, we would start with moles, we would use the mole ratio, okay? Or we could start with moles, use the mole ratio, convert to grams. Or we could start with grams, use the molar mass, and then convert to moles. So you can start and stop anywhere within those 4 steps. Or you could go all the way from grams to grams, which is most often what we're going to be using. So most of the time it's going to be this 4-step problem. Okay, so let's go through an example of how we do some of these calculations. All right, here's our example. It says, one disadvantage of burning propane is that carbon dioxide is one of the products. How many moles of CO2, and that's one thing we want to know, are produced when 10 moles of C3H8 are burned in excess oxygen in a gas grill? Okay, so we are given here, and what we're trying to find, what our unknown is here. So we always start with what we're given, 10.0 moles of C3H8. Okay, now we already have this balanced equation, so you'll need to refer back to that balanced equation. You might want to rewrite it again when you're working the problem, but we already have this balanced equation. So let's make sure we know C3H8 plus 5 O2 yields 3 CO2 plus 4 H2O. Now, if you didn't already know it, you would need to write the balanced equation. Okay, so we're given moles, we're trying to find moles. So we don't have to do anything with molar mass this time. There are no grams involved. So the only thing we're going to need is the molar ratio. Now, the moles of C3H8, they go on the bottom because that's what we want to cancel, right? So from our balanced equation, how many moles of C3H8 do we have? 1. So 1 mole of C3H8. And then what are we trying to find? We're trying to find moles of CO2. So that's what goes on the top. 3 moles of CO2. Okay, so our moles of C3H8 cancel. And now, when we multiply, we would see we get 30.0 moles of CO2. Okay, so that's going to be your very basic problem where you're just going from moles to moles with your molar ratio from your balanced equation. Okay, so now let's look at another one where we put some gram calculations in there. Okay, so for this one, we're going to have to write a balanced equation. This is a new one. It says, determine the mass of sodium chloride, commonly called table salt, produced when 1.25 moles of chlorine gas reacts vigorously with excess sodium. So the first thing we want to do is write our balanced equation. So what two things are reacting with each other? Well, it looks like chlorine gas reacts with excess sodium. So chlorine gas, it's one of our Hofbrinkels, Cl2, reacts with sodium, which is a metal, Na. And what's it producing? Sodium chloride, which is NaCl. We look at the charges, +1, Cl is -1, so 1 of each. And then to balance it, we put a 2 here and a 2 here. All right, we have our balanced equation. Now we can do our calculation. So let's think about what we're given. 1.25 moles of chlorine gas. That's what we're given. So that's what we're going to start with. 1.25 moles of chlorine gas over 1. And what are we trying to find? We're trying to find the mass of sodium chloride. Okay, so if we go back to our 4-step formula, if we have moles, we have to go to the mole ratio next. So we're trying to find sodium chloride, that goes on the top, 2 moles of NaCl. We want to get rid of Cl2, so from the balanced equation, 1 mole of Cl2, so those will cancel. Okay, now, because the question asks for the mass of sodium chloride, we have to use the molar mass. So from your periodic table, add up the molar mass of Na plus Cl, and that's what we're going to use here. So our molar mass would be 58.443 grams of NaCl per mole of NaCl. So our moles are going to cancel. We have grams of NaCl. That's what we want our answer to be. And if we look back at our beginning number, we have 3 sig figs. So our answer with 3 sig figs would be 146 grams of NaCl. There we go. Okay. All right. So now our next example is going to go all the way from grams to grams. Okay, so we're going to do all 4 steps in one. Okay, again, we're going to have to write a balanced equation, so let's see if we can figure it out. It says ammonium nitrate, an important fertilizer, produces dinitrogen monoxide gas and H2O when it decomposes. Determine the mass of H2O produced from the decomposition of 25.0 grams of solid ammonium nitrate. Okay, so let's write our balanced equation. Ammonium nitrate decomposes. So figure out the charge of ammonium and nitrate, put those two things together. So NH4NO3 decomposes to make dinitrogen monoxide. Dinitrogen monoxide and H2O, water. Okay, then we balance our equation, and to balance it, let's look at what we have. We have 2 N's and 2 N's, that works. we have 4 H's, so we're going to have to put a 2 right there, and then 3 O's. 1 plus 2 makes 3 O's, so those are balanced. Okay, so now we want to do our calculation. So we start with what we're given, 25.0 grams of solid ammonium nitrate. 25.0 grams of NH4NO3 over 1. All right, so now going back to our formula, we have grams, we have to turn it into moles. So we're going to need the molar mass of ammonium nitrate from the periodic table. So 1 mole of NH4NO3, if we add them all up, would give us 80.043 grams per mole. Okay, so our grams cancel. Now we use the molar mass from the periodic table. So we need to figure out what our unknown is, what we're trying to find. And it says determine the mass of H2O. Okay, so H2O goes on the top. 2 moles of H2O. 1 mole of ammonium nitrate goes on the bottom from our balanced equation. Okay, so those moles are going to cancel. And now we want to get the mass of H2O. So the last thing we do is the molar mass of water, which is 18.015 grams of H2O per mole. So those moles cancel. We're left with grams of H2O. That's what we want our answer in. We come back here, we see we have 3 sig figs. So when we do the calculation, we get 11.3 grams of H2O. There we go. Okay, that's how you do stoichiometry.